for Unit 8 is on quadratic equations. If you have checked Canvas, you may notice that there's not much there because I'm behind on planning. But I'm going to work on that some, even though I've still got to grade that last stuff to finish up grades today. But for your class, your grades are done, so yours should be done. You have what you have for third quarter, unless you find an error or something, which you need to let me know about right away. So we've got Unit 8, which is going to be quadratics and quadratic applications, and then we've got statistics, and we've got a geometry unit. So we got 3 more to go before we get to the review for the exam. So we're getting really close to the end here. Quadratics are a pretty big part of the exam, so it's going to be really important. And today we're going to learn about solving quadratic equations like we solved regular equations. So it's going to be similar to solving just like an x plus 7 equals 5, except for they're going to be quadratics, which means they're going to have a square in the problem. So this is going to be section 8.1, and this will be part A of the notes. It'll be broken into 2 parts. Let's come back. Good. Good. None of your business. We're doing math now. Okay. So quadratic equations. Quadratic. Let's do a little bit of vocabulary here. Quadratic tells us that our highest exponent is 2. That means we got an x squared in the problem, and you don't have an x cubed or x fourth or x to the 5th, which we're not going to see because that's not covered in this level course. And then an equation. We've done equations a lot. What is an equation? What makes something an equation? An equal sign, right? It's an expression with an equal sign. So if you think about what we were doing for the warm-ups, those were quadratics because they had an x squared. But they were not equations. There was no equal sign, right? They were what we would call a quadratic expression. It does not have an equal sign in it. So today we're going to be looking at something that has an x squared and it has an equal sign in it, right? And when we have equal signs, we're looking to solve this down to a number. So we want x equals 5 or x equals 2. Or we're going to see that a lot of quadratics actually have 2 answers instead of just 1. So let's do our first example. It's going to be super simple, but let's see if anybody can get the answer right. Okay, so we have x squared equals 36, and we're trying to find out what x would be. So, Peyton, what do you think? Okay? You are partially right. There is another answer.
Is it a 12 or 16?
I'm looking for an x equals. There's another number that'll work. Okay? When I square 6, 6 squared is 6 times 6, which gives me 36. 3 won't work because 3 squared just equals 9, so it doesn't equal 36.
thinking it's just.
There's another answer. There's another answer. Put that away under your desk. There's another answer.
Is it 2?
Why would 2 to 2
I don't know, y'all. I'm trying.
8 squared to give you 64. Oh, Presley has said -6. -6 squared. Now, if you put in your calculator, you gotta have parentheses around it. Would be -6 times -6, and negative times negative gives you a positive. So 36 there. So, whenever you have something squared, so let's do a second example here. Another really simple example, x squared equals 100. Okay, so a way that we can think about this is, what is the inverse of a square? A square root, right? Squares and square roots are the opposite of each other. So, so if I square root both sides here, the square root gets rid of the square, and the square root of 100 is 10, but also need -10. So, the symbol that we use a lot of times for this when we square root both sides is we will just put a plus or minus in front of that 10. Okay? So what that means is that I have an answer of x equals 10 and x equals -10. I could write it as two separate answers, or I could just put that plus or minus in front of the 10, and that tells me I've got two answers, a positive 10, -10. Yep. So you can either write it like this. It looks like one answer, but it's actually two. Or you could write them as separate answers. Here, we're going to use that plus or minus notation a lot because, as we see, it's going to help us when we get to the more complicated problems. So let's write this over here to the side. When you take the square root of both sides, you must put a plus or minus with the answer. And that will cover the positive and negative there. Okay, questions so far? All right, I'll give you a second to make sure I have time to copy that down. Okay, so, let's do an example that's a little bit tougher. Okay, so when we solve these, we solve them just like we solve regular equations. The only difference is we're going to have a square, so there's going to be a step somewhere where we need to square root both sides. Wade, what should we do? Okay. I'm going to add that 8 first. Okay, very good. Just 4? 4 and negative 4. So, to get rid of a square, this is really important, okay? Because if you don't understand this part, then you're going to have a lot of trouble on these. The inverse of a square is a square root, right? So, to undo a square, we use a square root. So, if I need to get rid of that square, I'm going to take that square root. And if I square root one side, I have to square root the other. And so when I do that, the square and the square root just cancel out, just leaving me the x, which is what I want. And then the square root of 16 is 4. But when I square root both sides, got to put this plus or minus there. So we got positive 4 and negative 4 as our answers.
So it's just like canceling out.
Yeah, the square and the square root cancel each other out. Yeah. And remember, whenever you take a square root, you're asking yourself what number times itself gives me this value, right? So there are lots of square roots that we know the perfect square. So like 16, we know 4 times 4 equals 16. So the square root of 4 is 16. Let's look at this type of problem. Okay. So we're trying to get that x by itself. We're going to start furthest away from that x, so we got to get rid of this 9. Alyssa, how will we get rid of that 9? Good. Very good. Make sure you don't lose that negative right there with the x squared. And then we'll have negative, not 17. They have the same signs when you add them together, so we'll get 21. Okay, now the square, whenever you just have an x squared like this, it's the last thing that we want to deal with. So I got to deal with this negative out front, which is like having a negative 1. So Peyton, how do I get rid of that negative? Yeah. I'm going to divide both sides by negative 1, which will give me, where I've got negative divided by negative will give me a positive 21. So, my last step here, Katie, what would I have to do? I'm going to take the square root. Now, notice here, it's really important you know that, take that square root instead of just like plugging in numbers in your head, because do we know a number times itself that gives us 21?
4.582575.
Okay, we don't know that in our head though, right? You didn't pull that out of your head, right? So we got a square root, which is going to give us an x right here. So for some of these problems, you're going to get ones that aren't perfect squares. So I'm going to go with decimals on this. We're not going to simplify radicals because I just don't want to, and I don't think you have to for the exam. So you'll have your calculators for these. And if we do, to do a square root, everybody open up your calculator, everybody. Because I want to make sure everybody knows where this is at, because it's not that easy to find. Okay, there's not a square root button that has a picture of a square root on it, but if you look above your x squared button, there is a square root in blue. So if anything is in blue, that means you have to hit the blue button first, and then hit the x squared squared button. So if you hit the blue button, and then x squared, and then you can type in your 21. Then you can get that value. So we're going to get 4.82. Unless I tell you otherwise, round to 3 decimal places on these for me. Okay, so we're going to do, if I round that to 3 decimal places, what will I get? 583, right? Because I know we had a little trouble rounding before. Let's make sure everybody's with me on that. So where you got that 4.58255756. We need to cut this off at 3 decimal places. If this number right here is 5 or larger, we round up. So that's going to be 4.583. And what am I forgetting? I need a plus or a minus here. Because it could be positive or negative. So you're going to get some of these where you're going to get, you're not going to get perfect squares. So you're going to have to use your calculator for that.
So you're not like dividing 24?
Right, it's not dividing, it's taking the square root of 21, which means what number times itself gives me 21. Now you'll notice, because I rounded this, if I do 4.583 times 4.583, if I square it, it's actually going to give me like 21.00. That's because I rounded it off. If I took this number right here, the whole thing, and multiplied it by itself, it would give me exactly 21. But because we're rounding, it's going to be just like a hair off there. Okay. Questions? All right. Most of them you're not going to need your calculator for, but there will be some that you need your calculator for. All right. Let's try a different type. Um, 6x squared plus 2 equals, let's see, 22. No, make that 26. I could do 22, but. Alright, Owen, tell me what to do first. Okay. So that just leaves that 6x squared over there on that left-hand side. We get 24 here. Okay. Now, very good. We want to divide by that 6 because we want to get rid of it before the square. Right? Square's last thing in most cases. So we divide by our 6. What do we get when we do that, Owen? Very good. So once we get down just to that square root, we square root both sides. Square root of 4 is 2. And we have to put that plus or minus with it. Okay. Questions so far? Alright, so for everything we've done so far, the square root was our last step. And there are many, many, many times square root's going to be the last step. But there are some where square root is not your last step. So let's look at this. Okay, so we've got x minus 1 squared equals 9. And so for problems like number 5, my square was my last step. It was the closest thing to my x. But is the square the closest thing to the x in this problem? It is not. I've got this x minus 1 is together, and then it is squared. So for this problem, I'm going to square root both sides first to get rid of that square. So here's the tricky part about this. Square root and square just get rid of each other. You just have x minus 1. That's not bad. All right. But when I square root that 9, what am I going to get? All right. Almost. But when I square root both sides, what do I have to put with that answer? Plus or minus 3. You must put that plus or minus there as soon as you take the square root. So you can't wait till the very end to put a plus or minus here. So as soon as you take that square root, you've got to put that plus or minus there. Now, I can't really do this equation with a plus or minus because that's really two different numbers, right? So this problem is going to have two different answers, not just the positive and negative of that same number, but two different answers. So at this point, as soon as you get the plus or minus, you need to make this two equations. So it's x minus 1 equals positive 3, or x minus 1 equals negative 3. So we have to split it there into two separate equations. And it should leave an equation left that's pretty simple to solve. So for that first one, Hank, what should I do to solve that first one? Good. And what do I get for my answer? Very good. So there's one of my answers. What about the second one, Hank? Very good. What's my other answer? Negative 2. So you get two answers for these, but it's not just the plus or minus of that answer, right? You're getting two different answers here. This is going to happen when you see some stuff in a parentheses with a square on the outside, right? If it just has an x squared, you're probably not going to have to do that. Okay, questions so far? All right, let's try one that's a little tougher. Now, on this one, I see parentheses with a square on the outside of that parentheses. That tells me I'm probably at some point going to have to break this into two equations. But the first thing that I need to do here is I need to get that set of parentheses all by itself. Okay? So, Owen, what should I do? I'm going to divide by 5 because that 5 is being multiplied by this stuff inside the parentheses, right? So I'm going to divide this by 5 here and divide by 5 over here. So I've got x minus 4 squared equals 7. All right, Julian, I've got x minus 4 squared equals 7. What's the next thing I'm going to have to do here? What would I multiply by? Okay. I need to get rid of that square right there. Passion, what do you think?
I know it's going to just be x minus 4, but I don't, how we can take that in?
Yeah, take the square root. That's what we need to do. So, and to make sure we're clear on, how to explain it, because a lot of times people can't tell me what to do, but they can do this, right? So, this is called taking a square root. So we take the square root of both sides, which gets rid of that square, so we just have the x minus 4 here. And then, do we know the square root of 7 off the top of our heads? No, we're going to have to go to the calculator here. So remember, second, that blue button, and the x squared gives you the square root here. Square root of 7 is going to be 2.6. Oh, round it for me. Easton, what's that when you round it? Yep, 2.646. What am I forgetting? Plus or minus. If you forget that plus or minus, you'll get one of the answers correct, but you'll be missing the second answer, which means you'll only get half credit for it. So we're not done, but we do have a plus or minus. We cannot continue with a plus or minus. So, Julian, what am I going to have to do with that plus or minus? Make two equations. So x minus 4, it could equal positive 2.646. Or you could have x minus 4 equals negative 2.646. So, Julian, whenever we have that plus or minus, at that point you want to split it into two equations because you can't solve it with a plus or minus there. And Julian, how do I solve that first equation? We got to get rid of that minus 4. How do we get rid of that minus 4? Good. So we'll add the 4 to both sides. So x is just going to equal 6.646. So there's one of my answers. What do I do for the second one, Julian? For that second one, I've got x minus 4 equals negative 2.646. What will I do to get that x by itself there? It's this negative 4 that I got to get rid of. So I'm just going to add 4 again. You'll find out it's usually the same thing to solve both equations, right? So, Julian, what do I get whenever I do negative 2.646 plus 4? Do that one for me in the calculator. I'm waiting on Julian. So you're doing negative 2.646 plus 4. What do you get when you do that? What did your calculator give you? Did it give you an error? If it gives you an error, like if it doesn't give you an answer, you're probably using the minus key as your negative, which you can't do. So the negative key is next to the period, next to the decimal place right here. So that negative key, you got to do negative 2.646 plus 4. Did you get it to work that time? Okay. So 1.354. So those are our two answers there. Okay. Questions? Let's do one more that'll be our most difficult one before I give you guys your assignment that you're going to do. Let's do 12 equals 5 minus, no, it's got to be plus 3 times x plus 1 squared. Alright, so this will be like the most difficult type of problem that you're going to see for this section anyway. So Ayla, what would we do first trying to get that x by itself on this right hand side? If there were any like terms, we would combine them. But the 5 and the 3 cannot be put together. We're eventually going to do that. But in general, you want to try to get rid of whatever is furthest away, which in this case is that 5 right there. How could we get rid of that 5? We're going to subtract the 5. So we're going to subtract the 5 first. So that's going to give us 7 equals 3 times x plus 1 squared. So because it's separated out by that plus sign there, you just subtract it to move it over to the other side. Now we still have stuff that's on the outside of those parentheses, so we need to get rid of the 3 and the square. We want to deal with the 3 first. So how do we get rid of that 3, Ayla? Not yet, because we don't have a plus or minus. We're going to wait until we have a plus or minus. Can't subtract it. Okay? We're going to divide, because this 3 is right next to those parentheses, right? There's not, this 5 was not. There was that plus sign in between, so we subtracted it. So this 3 right here is right beside of those parentheses, so it means it's multiplied. To undo that multiplication, we're going to divide. So 7 divided by 3, it's even an ugly decimal. Well, it's not that bad of a decimal, but I'm just going to leave it 7/3 right now, or you can get decimal. Either one is fine. All right, questions so far? All right, what now, Ayla? Kinda. I got that square. I got to get rid of the square. How do I get rid of the square? Okay, the inverse of a square, Jada? Square root. So we're going to square root this side and square root this side. And that's where that plus or minus is going to show up. So when I do the square root of 7 divided by 3, that is going to give me 1.528. But when I square root both sides, that's where I got to put the plus or minus. And we're not going to make two equations until we've got that plus or minus. And then over here on the right-hand side, the square and the square root just cancel each other out. So I've got x plus 1. So for these types of problems, you're not going to have to make two equations until you have square rooted both sides. And so this tells me I'm going to have 1.528 equals x plus 1. And I'll also have negative 1.528 equals x plus 1. And so, Ayla, how do I solve that first equation? Are you sure about that? Okay, good. So if I subtract 1 from that, I'll get 0.528 equals x. And then for the second equation, Ayla, what am I going to do? Still subtract 1. That's going to be negative 2.528 for my x. So I'll get both of those answers there. Not really. This is the shortcut. There's other ways you could do it, but it would be longer than this. Okay, questions? Okay, so I have a worksheet that we're going to